Hello, my name is Cody Anderson. This is my capstone project presentation for ABS 494 Senior Seminar. My topic is Enhancing Pilot Decision Making to Prevent Controlled Flight into Terrain, CFIT, Accidents in General Aviation. In this presentation, I'll explain what CFIT is, examine its contributing causes, and share how pilot decision making improvements can reduce its occurrence in general aviation. Controlled flight into terrain, or CFIT, refers to situations where a functioning aircraft under the control of the pilot unintentionally impacts terrain or obstacles without any apparent mechanical failure. These events often occur in instrument meteorological conditions, IMC, or at night when terrain visibility is limited. CFIT is one of the deadliest types of accidents in general aviation. Unlike commercial airliners equipped with advanced terrain awareness systems and multi-crew environments, general aviation aircraft typically lack these resources. As a result, general aviation pilots are more reliant on their own decision-making, making them more vulnerable to CFIT. Several factors contribute to CFIT accidents in general aviation. These include deteriorating weather, failure to divert when appropriate, misinterpretation of terrain data, over-reliance on automation, and even pilot fatigue. Often these factors compound under pressure, particularly when pilots feel committed to completing a flight despite the risks. Decision-making plays a central role in preventing CFIT. Many accidents could be avoided if the pilot had made a better go or no-go decision or recognized the red flags earlier in the flight. Tools like this DECIDE model help structure those choices, guiding pilots through risk assessment and mitigation steps. Additionally, there are models like the 3P and PAVE models. In one case examined, the accident involved a pilot on a routine VFR mission who continued into poor visibility and flew into rising terrain without making the planned turn toward the coast. The aircraft impacted a near vertical mountainside in a controlled wings level attitude, indicating no mechanical failure. The NTSB concluded it was a classic CFIT accident caused by the pilot's poor decision to continue VFR into IMC, despite the limited visibility and the availability of alternate options. This directly supports my presentation by showing how breakdowns in situational awareness and decision-making, especially under pressure, remain leading contributors to CFIT accidents in general aviation. To address some of these risks, training programs must emphasize scenario-based instruction that challenges the students to make real-time decisions in dynamic environments. Simulators should be used to replicate poor weather, system failures, and nighttime terrain hazards. Risk management tools like the PAVE, 3P, and DECIDE models should be integrated into every training stage. Technology can also assist in preventing CFIT, especially systems like terrain awareness and warning systems, TAWS, and synthetic vision. While these tools are becoming more available in general aviation, they require pilots to remain engaged and interpret warnings correctly. Over-reliance on automation without solid judgment still leads to accidents. To summarize, CFIT accidents in general aviation are often preventable. By improving how we train pilots to make decisions, especially under stress or in poor visibility, we can break the chain of events that leads to terrain collisions. Realistic simulator training with scenario-based training methods and regular use of decision-making frameworks are essential. Thank you for watching my presentation. I hope it helped demonstrate how focused pilot training and stronger decision-making can play a key role in preventing CFIT accidents in general aviation.